Hey, welcome back, guys. I know in that last video was just like a really short and rough update on the progress of things so far. It's been a while with the holidays and everything and waiting for parts to get back in stock and get shipped to me. Took a while, a lot longer than I anticipated. So anyway, I've been trying to get back into it and keep things rolling along. So what I've been working on in the meantime is the 3D print. So I'm going to show you some of that right now. All right, so we're in Onshape here is what I've been using. I've tried Fusion 360. I generally like working on my Mac, and I find Fusion just doesn't work very good on it. It's too slow and clunky and takes forever to load. I'm going to start this by saying I'm not an engineer. I don't do this stuff regularly. I'm a novice at best. So anything you see me do here, if it's cringeworthy, you can point it out if you want. But anyway, let's just dive in. So I'm in Onshape. If you go into Onshape and you want to find the project I'm working on, search for something called DFP V2. I just pick random character. I guess you could say it's PFD backwards. That's probably an easy way to remember it. I just use random names for projects because you can use Onshape for free. Whatever you're working on is in the public though, so anybody can find it and view it and stuff. And sometimes I just like to use random names for things until I'm ready to let people know about something like this. So if you do a search DFP V2, it should pop up. You can then fork it and you can make your own adjustments and stuff like that. Tweak it however you want. Feel free to do so. That's what Onshape is good for. So I'm going to click into this, and you can see here once it renders, I've got basically the outline of my G1000. I've got all the buttons, and you can see I don't have like the little arrow indicators on all these buttons. I don't actually need all these buttons in this design. I need the corner button because it's got a rounded edge, and I need one of the regular buttons, and I need both of those and a triangle for them, and then I can just export them and print multiples of them. I just did it in here for looks, but I didn't go all the way as to add, all the little triangles and things. So, this file is going to need some explanation. And like I said, I'm no expert at Onshape or 3D CAD of any kind. I'm just a novice at best. So I'm probably not using these tools in the right way, and I probably don't design things in the right order in the way that an engineer would do it, that would keep it nice and organized and neat and everything. So if you come in here, it's going to be probably pretty messy. I'm just going to warn you right now. Because somebody's going to try and use it and get frustrated when they make changes and stuff. So there's a few things that I think I need to explain though. And if you want to find this file and you just want to print it out yourself, there's a few things you need to know. So I've obviously added all the text to the parts in here. You can either just leave the parts how they are and then add text in some other program, like I'm using BambuStudio because I can print multiple colors. I could add the text to the part in BambuStudio. It's kind of a painful process, and I don't like to do that. So I just add all the text here in Onshape, because then I could kind of get it exactly where I want it and move it around, although you don't get a lot of text options in Onshape. That's one downside to using it. There's only, maybe a dozen or so fonts available to choose from, and it doesn't give you a lot of control over that. So here we are. Let's just dive in. So one of the things that I have to do in order to get text to print right is that I want all my text backlit. So that means that this white nav has to go all the way through to the backside so that the lights from the circuit board will backlight it, right? Makes sense. But when you do that, you're actually cutting the text into the part. And if you look at this A, you would have this little black part that's an island all by itself. So when we cut the text into the part, what we end up with is a whole bunch of fragmented parts. And you can see I'm scrolling forever. I'm just trying to look for the left frame. So if you look at this, if I just kind of run my mouse down here and you look at what's going on, it's kind of highlighting some orange areas. And those are all the little, the little circles in the P's and the O's and the A's and the D's. So all those things are their own individual parts. And what I need to do is basically export all those as if it were one part to my slicer, to BambuStudio. So what you have to do, the reason why this is the way it is, and in Fusion, I know you can take a whole bunch of things like this and you can right click and add them to a folder and then export the folder as one part. You don't have that in Onshape, but you can select all these left frame parts. You can come here to export. And then when you come here, you can name it whatever you want. You got to choose STL. I haven't tried anything else other than STL and 3MF files. 3MF files sometimes don't import right into Bamboo when I do this. So I just always choose STL. You'll want to do the same. So I'll take STL and I'll name it. I'll name it left frame. Let's just be clear about it. And then obviously choose STL. Like I said, you can leave the rest as it is. Binary millimeters is what I use. Fine resolution. I just download it directly. The one thing is sometimes this box is checked. You do not want to export these as individual parts. Otherwise, you'll get every single left frame will be its own part that you have to import into BambuStudio or your slicer or whatever, and then align it all correctly. Don't do that. Definitely leave this unchecked, and it will export all those pieces that you have selected. It will export them as if it's one complete unit. So I'm going to show you that here right now. So I'll hit export, and then you can see the export happened pretty quick. Sometimes it is slower. It just depends on how busy their servers are. Most of the time it's pretty quick. So if I come over to BambuStudio, so I've got a fresh project here. I'm going to go to my downloads, and you can see I have this left frame STL, and it looks like I missed something when I exported because I don't have the whole part. I just have all the little individual pieces here. These would be like the little gaps inside the letters, like in the P and the D and all that stuff. So I didn't export that right. I missed something. So I'm going to go ahead and just delete this. And we're going to go back to Chrome. And I'm going to make sure, oh, see right here, I missed it. There's one more left frame right here. I had to grab this. This is the rest of the left frames. So let's do this again. So we'll grab all this. We'll come export, STL. I'm just going to name it left frame in all caps because I like to scream it myself. We'll export that. Okay, so now I'm back in Bamboo with the new project. I can go to my downloads. I can select left frame, and now you can see I got the whole left frame. And if you zoom in here, you can see that we've got all these the floating regions and stuff. It's all there. It's all lined up. Whoop. Let me see if I can change my view a little bit. So you can see that it's kind of hard to see where the clear stuff is or the cutout. And then you just have like your little floating islands and stuff there. That's okay because we're going to put the text in next. And I'm going to go back to Chrome and I'll show you how we do that. So let's go back to Chrome. And I can click off of this to deselect it all. And then now what I have below the left frame, all these are just individual parts. So when I created the text and I cut it out of the frame, it's going to create an individual part for every single letter, which is also a pain. But especially because I didn't have any names already set for these things. So now you just get like part 128, blah, blah, blah. If you go all the way up until you see right frame, that should be all of the left frame parts. That's not including the buttons. The buttons are different. We have to export those individually as well through this, similar process. So we'll take all of these left frame text parts and then we'll go ahead and export again, STL. All our settings are saved from last time. So then I'll scream at myself and say this is left frame text. And again, make sure you're not exporting all of these as individual parts. It all needs to be one. So we'll export that. And then we come back to Bamboo. And actually, I'm going to do this in a slightly different order. And I'll tell you why. Actually, no, I'm not. I'm going to show you why really quick, why you want to import the text first and then this frame later. And I'll show you right now what happens. So I'm going to import my left frame text. We go like this. I have 4 different colors here, or 3 different colors, and some bamboo support material, filament. So I want to make my text white. So I can just hit 2 and all that text is white, which is great. But what I want to do is actually, and I got somebody on the internet, I saw a video of some guy building a 737 panel. I can't remember who it was. If I can find it again, maybe I'll post it down in the comments. Somebody was doing their own panels, and they showed how they were printing theirs with the backlight, which was I actually liked better. I would print mine solid white, and it doesn't get quite as bright as I would like it to be. And this guy was doing clear PLA for most of it, and then the last couple layers switches to a white PLA on all of his text. And that actually works really well. I really like that approach. So what you can do is you can come in here, and with my text still selected, I can come to my color. Actually, let me back up because it's all white. We want it to be clear and then transition to white. So I have this pink generic PLA. This is actually my clear PLA. I just make it pink because there's no way to represent clear in here. You know, sometimes I choose white or gray, and then I have white and gray filament, and I can't tell them apart. So I just make it a bright, bold color. That way I know wherever it's pink, that is clear. So I'm actually going to change the base color to pink, which is clear. PLA in this case is what's loaded in my machine. And then I will come to the layers, and I'll do something like maybe 0.6. And then I can just basically wait until that top line is right at the top, and then I can click it, and now I've got 0.6 millimeters of white, and all the rest is going to be clear PLA, which in this case is represented as pink. So now what you can do is you can, it's easy to right click on that and then click center. But the problem here is that now I can't get it anywhere above the build plate, because as soon as I lift it up, it snaps back down to the build plate, because you can't print PLA in the air. What most people do is they'll come over here to the objects tab, and then you can see my 2 parts, the frame itself and then the text. You can click both of those and then click merge, and now you have this assembly. It's basically treating it all as one part. Once it's one part, similar to how when I exported the frame here from Onshape, how you have like the little floating islands, it's because it's all one part. So now that we have everything combined into one part, I can still come in here and select the text by itself. Now I can move it up, and it will stay there wherever I move it. So this is the part that's a little bit of a pain, because you have to get it to where it's like just right there. I actually like printing my text a few layers above. I seem to get better results when I do that. So in this case, I would actually come with left frame text only selected. I'll come to the scale, and instead of uniform scale, I want to uncheck that because I want to make it higher in the Z axis. So right here, it's 1.4 millimeters. I want to go like 1.6. So it'll give me like basically 2 layers above the face of this. And you can see when I scale it, it scales equally in both directions. So it's basically 0.1 millimeters higher and 0.1 millimeters lower. So I still have to bring it up just a little bit more. Right now it's at 6.55. I could probably just go 6.65. Was probably pretty good. I don't see any pink showing through. So that's probably pretty close. So now what we got to do is line it up in the X and Y axes. So, and this is the process that's a little bit tedious. I find it easier to kind of look top down, zoom in as much as you can, where you can still grab the controls. So I'll try and get the X direction lined up as best I can, and then for whatever reason, the Y axis little move tool up here ends up way at the top. So it's kind of annoying that you have to keep moving around. And now I accidentally unselected my text, so I got to come back here, select it again, and then now I can move this up to where the white edge just touches the clear part, and it's hard to tell because the colors are so close. The black is so close to the background gray. But I find if if it looks pretty good, it usually prints okay. So there it is. That's it lined up. And then if I come around to the back side, you can see it's all the pink color, which means that's the clear PLA showing through. And if I zoom in here and kind of move around, you can see it looks like it's pretty much flush with this back face. So I think that's actually okay. I have tried printing this face down on the build plate. I find the text usually doesn't work out well when I do that. Sometimes it gets a little screwed up. I find it prints better face up. Some of the text that's smaller, especially this push heading sync and the push 1-2 and the push ID, sometimes because they're a little bit smaller text, I had to make it bigger than it really is on the G1000, but it's still pretty small, and that's about the smallest text I can print and still get okay results. Sometimes when it's printing the very last layer or two, I get some extra white crap. It almost looks like it just drags the head across it almost and kind of pushes some of the plastic around, so it doesn't look great, but once it's backlit, it looks fine. I'll have to show you that when I get one printed. But for now, this is basically what I do. This is the process. And then a couple of things to note is that I've noticed when I do it this way, it's complaining about some floating regions. Oh, I don't have any supports. I didn't enable supports, so we're going to ignore this for a minute because I just want to show you something. So a lot of times when I come in here and I look at, looks like my nav text is a tiny bit off, but anyway, that's beside the point. Let me move up to here. So sometimes when I come in here and I kind of go down through these layers, oh, this one actually looks okay. Never mind. Sometimes when I get to a layer like this, where it's like, you can see we got nice defined lines, sometimes you will get like some black that covers all of this, and that obviously won't work. But in this case, it actually looks okay. And if you look here, like this is an example, like you get some extra white around this D and the G and in between the H and the D. It's weird. I don't know why it does that, but that's just the way it slices. Sometimes that happens with the black though, except it comes over the letter. You definitely want to avoid that. So in this case, it's fine because it's going to come back over that extra white. It's going to come back over the top of it in black, and that's going to be okay. That's going to turn out all right. And you can see it's not perfect when it slices and stuff because we're really pushing how thin of lines we can actually get. Like if we zoom way in, you can see you get some weird little bits where it doesn't quite print the black across this extra white gap, and maybe up here, actually that might be a seam. I have seams turned on, so that makes it look even worse. But if you play around with this, sometimes you'll notice like sometimes it just doesn't work out to where your text lines are so thin that it's thinner than what the nozzle can do. You could go down to a 0.2 nozzle and get even better results, but the difference between like a 0.4 nozzle I can print this in 3 hours in this orientation with supports. If I do a 0.2 nozzle, it takes about 12 hours. So, I mean, that's a 6-hour difference. The text will look a lot better with a 0.2 millimeter nozzle on the printer, but I find that the time savings is well worth it. So I just stick with the 0.4 millimeter nozzle, and just deal with any imperfections in the text that I get, knowing that usually when it backlights, it looks pretty good. So yeah, I was going to show you why I generally don't do text that way. And it turns out that actually worked, because a lot of times when I've done the text this way, when I come look through the layers, that's when I get weird black obscuring the letters in some in-between layers. That didn't happen this time, so I don't know if there was an update that changed that or what. But that's how you can do your text. And now you got everything in your assembly together. So if I select, what am I doing? I'm in the preview mode. I always get confused with that. So if I go to the prepare mode, you can see now, because this is all one assembly, if I click on this and I drag it around, my text moves with it because it's all one piece. So that's one way to do it. So let me show you one other thing that I do. There's a couple different ways to do this. I'll just go through them all so I can show you everything that I know. Let's start with another one. We're going to start with the left frame. And there it is, centered up. Another thing that you can do is, instead of putting the different pieces on the plate and then merging them together into one, you can also right click on this part and you can say add part. You can add like cubes and cylinders and all these things, but you also have this load option right here, which means you can load another file like an STL with text, for example. So now I can come here and I can set that text to pink, which is clear, PLA in my case. But the challenge here is if I want to color it. Now you can watch what happens here. We're still at, let's do 0.6 for the height range. I'm going to zoom in quite a bit here. And we go right till that top line is on the top. And I just click, and now everything there is white and clear. It ends up coloring the frame as well when I've added. Oh yeah, see, there it is. So because I right clicked on the part and I did add part and then loaded it in, well, now it's coloring everything as one part. So that's why I tend to, if I'm going to do it that way, let's start over. Let me delete that. What you have to do if you want to do it this way is you have to import your text first. And then let's go, the base color will be our clear. And then we color it here. So let me angle this a little bit more. And then, whoa, my mouse is going crazy. So there you go. We got our color set. So you can do the text first, and then you can add the part and load in the frame. And if I open that, it's going to come in pink, but I can color this as long as I don't need any additional colors. And this is just going to be all one color. I can just do that one color there. And then I can center that. And then I can come back to the text. And I can move it up again. And I can move it around whatever I need to. So either way works. Bring them both in. Color the parts individually and then merge them together. Or bring the text in, color that first, then add the frame to the text. And then that way it basically comes in already merged. The only difference is that this thing will say left frame text, whereas the other way I did it first, it calls it an assembly. So it's a little more clear actually that this is an assembly and this isn't. I mean, you can always rename it. And, you know, I could give it scream at me assembly. So either way, those are two totally valid options that you can do. I'm going to go ahead and delete this one. And I'm just going to put this back to the center for fun and reset our view here. And then one other thing I was going to show you is that right now, the way I have the supports or the bottom and top frames working is there's this little I don't know what that shape is. there's a little gap in there. I know it's hard to see in BambuStudio, doesn't draw it very well, but there's a little hollowed out section there where the bottom frame fits in. And then same thing up here. It's a little bit different size, but that's where the top frame will connect. I do not print supports in these. Your printer should be able to go across this gap just fine. It's not a long enough gap that even though there isn't any supports underneath it, it should be able to print that just fine. For the Bambu printers, they seem to do great with this. I haven't had any issues. But I have printed that with support in there before, and I cannot get the supports out. It's too tiny of a space. I can't quite get like needle nose pliers in there. And using my little snippers that I use for the 3D parts, the little cutters, I can't quite get enough grip on it to pull it out without just cutting plastic and then making a bunch of tiny little plastic piece messes in there. And a lot of times I still can't get the support material all the way out of there, which is going to affect how well the bottom frame and the top frame are going to fit in that hollowed out section. So I just don't print supports there. And the way to do that is, if you're not familiar, so normally in BambuStudio or Orca Slicer, if that's what you're using, you can come to the support tab, make sure you're not on objects, go to global, come to support, click enable support. I just use the defaults. In fact, let's slice this so you can kind of see it. But when we come in here, I know it's really hard to see with this black, but you've got support material all built up in here. Let's go down some layers. So you can see inside the hollowed out section, we have these grooves going back and forth. Those are all part of the supports in that hollow space. I don't want that. So what I'm going to do is, again, when you right click on the part, you got a lot of different options here. You can add a part, you can add a negative part, which is like cutting something out. So if I wanted to, I could make this whole thing one solid piece, and then I could export text separately, load the text in, and that would make a negative part. It would cut the text out. That's an option. It'd be kind of a pain to do, but you could do it. The other thing here, you can see we have add support blocker or add support enforcer. So if you have an area that you want to add support where the slicer doesn't automatically add support, you can choose add support enforcer, and then you can add support somewhere where you wouldn't get them. But in this case, I want to add a support blocker. So again, you could load in a separate STL or something, or you could just choose cube, which is what I do because it's nice and easy to work with. So, whoa, where'd my zoom go? I'm all over the place here. So obviously this cube is huge. I'm going to scale it down. So I'm going to say something like probably 8 millimeters in height, and I don't know, maybe 10, maybe, yeah, let's try 15 in the Y, maybe like 12 in X. So what I'm going to do is I'm going to then come and move this, and I'm going to just try and line it up with that square. I like to come to the bottom side and move the X all the way until you see it poke out here. I go just inside of that to where you're not seeing the red anymore. That way I know it's all the way in the hole. You can see my alignment still off. So we'll just click on that, move it back down here just a little bit, and let's just make sure the whole thing is covered. I don't want to block any support underneath here, so I got to be careful about that. So I'm going to drag this up, and I don't have any supports on top, so it's fine if it's sticking out. But if I don't want it to stick out, obviously I can still shrink it down a little bit more. Maybe 6 millimeters is good. And then that way I'm blocking everything in this red block. If the slicer would normally put supports inside anything in this red block, now it'll prevent any kind of supports from being added in that area. So now if I slice this plate, you can see that, I know it's still hard to see because it's black, but let me scroll around here. Let's actually shrink this so you can see. So if we come around here, you can see that there are no supports added in this little box right here. I don't know if you can see it, but if I scroll over to this side where we still haven't added any support blocker, you can see it's still adding supports there. So the other thing you're going to want to do is come back to this prepare tab, and then basically same thing we did here, you'll want to do here to this one as well. So that's how I do it. And you can see if we come back to our slice here, you can see we've got, what we're using about 62 grams of filament. I haven't, oh, actually, you know what? I also would come back to the prepare tab, and then I use the support, bamboo support filament, which helps to get stuff off quite a bit. And when you do that, so I'm selecting support interface. So it'll build supports with PLA, and then right where the two pieces touch, the last couple of layers right here, where the supports butt up against the part, you can select those couple of layers to be the support material. So that way it doesn't stick to your part as well as the PLA does. So when you do that, you just do it for the support raft interface. And then when you select it, it'll bring up this thing and say, hey, you really need to change your top Z distance and your interface spacing. Do you want us to do that for you? Yeah, definitely do it. And you can see it made those changes here. So top Z distance is 0. Interface pattern changes to this rectilinear interlaced pattern. And then your top interface spacing is 0, meaning your interface, your support material is going to go right up against your part. So once you do that, slice your plate. And then we can see here, okay, so now we're about 75 grams of filament. It's not too bad. Our support filament, we're only using like 9 grams of it, which is really nice. Take just right at 3 hours to print, 2 hours and 59 minutes. So that's actually pretty good. So yeah, you do that and you're off to the races. So that's that. Let me show you, let's go back to Onshape. And let me show you some more things here. So in Onshape, whoa, what's happening? Okay, let me get back to, my keyboard's not working. Let me refresh this. Sometimes my keyboard just, like, the shortcuts don't work in Onshape, and I just have to refresh the page. Sometimes it times out and logs you out or something, so just refresh the page if you have weird quirks. Anyway, in here I have TF is the top frame, so I can turn these off. You also have the bottom frame. And then I also just created an outline of the LCD that I'm using. So that way I can figure out how to mount this thing. It's got these holes here. Your mileage may vary. I'm always tweaking this and then printing out little test pieces and trying it. And I don't know that I've got these holes quite right. I think the topmost and bottommost holes on both sides are right. So those four top and bottom corner holes, I think, are in the right position, but I'm still not quite sure that I've got these inside ones in the right spots. So I'm still adjusting those for the screen that I have. You may need to do the same thing, assuming you're using the same screen. I'll post a link to the screen that I've been using on Amazon. It's a little pricey. It's like $125, but if you want a screen this size and with pretty good resolution and backlight, this is the one to get. I still haven't figured out, the screen has 2 circuit boards that go with it. I still haven't figured out how I'm going to mount those yet. And I haven't really figured out the back shell for this thing. So yeah, The other thing is the buttons. The buttons, as you can see here with this blue cross. So I have the buttons, basically it's this, I'm doing the same thing where I'm cutting the text out of the button. So I'll print the text in clear and then transition to white PLA on the last few layers. And then I have this, so it's basically a cap. And then I have this little cross that I print. This is like the plunger that pushes down on the button itself, on the physical button, the tact switch. And so what I do is I print these separate. So this button is, I print just like the frame. I have to export the button itself, and then I have to export the button text, and then I line them up in BambuStudio just like I showed you and print them as one. I'll print those face down. And I like to print these face down, so this flat face is face down on my build plate, and I like to use the textured plate because it seems to look better. Even though it's got the texture, sometimes I don't love the texture for the G1000 stuff, but it's better than the smooth plate, I think. Anyway, I print these little pluses in a clear PLA, and they do affect the light just a little bit, but when you see it all together and complete, it actually doesn't, it's not really noticeable. And it's been working pretty good for me, so that's what I do, and I'll show more on that maybe in a later video, maybe in this video, I'm not sure. So anyway, all these buttons, you're going to go through that same process, and then all these little pluses, I just have one, so I export that one, and then I create multiple copies of it, and just put them on my build plate. So there's two different types of these little plungers or crosses or whatever they are. Also, I put these little guides, and that's what this cross fits into. So when you print these out, you got to make sure that you're getting them lined up so they fit in between these little gaps, and that helps hold the cross correctly in place, because sometimes they can twist and pop out if I don't have those. So that's that. There's also a different size cross that goes into these bottom buttons, because these bottom buttons are a different size. So I have one for basically these rectangular buttons, and then the end buttons that have the rounded edge have a different plus, but I actually, when I print these out, I think they're actually the same size. I could measure in here, but I haven't. I think they're pretty close to the same size, so you can just export one of those and then make multiple copies of it and see what you get. But yeah, so let me flip this back around. Let's turn all the parts back on. Whoops, and instead I just turned everything off. Let's come back to, you can see I've started working on the back shell. There's some issues with it though, and it's not ready, so don't print that. My idea here was to have the panel mounting screws here in these four corners to go all the way through that, through the circuit board. They'll come out here on the back, and then I'll probably have something that will screw into that screw and like kind of sandwich it against a frame that you print or something. I don't know. I haven't figured out a solution there, and I also had some problems that I can maybe show later. But I wanted to show you one quick thing. So, okay, so there's the large button plunger. That's this cross. Whoops, let me turn off where's the back shell? Whoops, there we go. So I call these plungers. I think that's the normal industry term. You have like a cap and then a plunger. So there's the large plunger, wherever that was, right here. So you want to export that all by itself. And then you can see on the buttons, same thing. I tried to be pretty clear about what's what. It's not perfect. I can't move this where I want. So you can see I have the vertical speed button. This is it says button, but it's actually the button cap. And then when I come down to like the text, like here for the autopilot, I have AP, and then I have A in quotes, so that's the letter. So this is the letter A, This is the letter P. And what you're going to want to do is you're going to want to take these 3 AP buttons. This is the cap. Export those. So this would be like AP button cap. You'll want to export that. And then you'd come down here and go, okay, I got the 2 letters A and P. Export that. Make sure this is unchecked though, so that you're exporting the text as one thing. And then you can just AP button text. So then you can export it like that. Same thing for flight director. You got the 2 for the cap. You got the 2 for the text. Heading, you've got H, D, and G. Make sure you get that. But then for just the button cap, there's only 2. And the reason why is because you have the whole cap itself, and then you have the little piece in between the D. So that's that. The other thing, if you want to see the knobs are in the knobs part studio. Couple things to be aware of. I have the heading knob and the volume knob are kind of embedded in each other, so you have to turn one off to see the other. And the reason why is because I imported a PCB here and kind of used this as my guide to get the measurements right. Some of them were still wrong, and I've had to like print them and test them and print them and test them and tweak them and all that stuff. But the volume knob is inside the heading knob. If the heading knob happens to be turned on, you can't find it. That's where it is. Just turn them off one by one. You'll start to see them. The course knob, the map knob. I'm not sure I'm done with the map knob, but I think it's pretty close. And then, of course, you've got the outer knob and the inner knob. And these fit the encoders that I'm using. So that's it for now. We'll catch you in the next one.